So again, here we have the repeated stratified k-fold. So I just call it RSKF. Now over here we have cat boost, and we should probably say that all the cat features are all of them. So it's all calls. Um, this helps when you're using cat boost. And basically, I'm fitting this. Now, here's the part that is important in my mind. I'm doing a cross-validated score, but what I'm basically doing is I'm using the Matthews correlation coefficient as my sort of scoring mechanism. And so I think that sort of deserves a little bit of talk about what the Matthews thing is. So let me just go to Google here, and if you look at the Matthews correlation coefficient, even this Wikipedia article will basically tell you a little bit about it. So as you can see here, let me put this in reader mode maybe, and let me just make this a little bit bigger. So Matthews correlation, or the phi coefficient, is a measure of binary two-class classifications, and it was introduced by Brian Matthews. So basically, the coefficient takes into account true and false positives and negatives, and is generally regarded as a balanced measure, which can be used even if the classes are of very different sizes. So that's sort of an important part, because a lot of the times data is the sort of distribution of classes is really quite wide sometimes. So the MCC is a correlation coefficient between the observed and predicted binary classifications, and it's usually between -1 and 1, where 1 is perfect. And so yeah, so the Matthews is considered one of the best measures, because accuracy and everything else basically is biased when the classes are not of the same size. So and the MCC can be calculated directly from the confusion matrix. So it's basically this formula where it's true positives times true negatives minus false positives times false negatives over the square root of all that stuff. And I don't know if I can really give a justification of this particular formula, but yeah. Um, so yeah, I guess this is another way of calculating it, and here are some of the original formulas. So basically, yeah, it's a balanced measure, and that's why I'd rather use this than the F1. And if you want to, one thing you could do is you could check out articles of that, or papers that say why Matthews is better than others. And so if you want to, this is one of the PDFs, the advantages of the Matthews correlation coefficient. So that's actually from this year. And you can say what are the advantages of Matthews over the F1 and accuracy and binary classification. And this one is free, so you can download this and read the entire paper, and so you can at least sort of see if you agree with it or not. Okay, so basically, I've decided to use the Matthews, and it's not that this is the be-all, end-all so much as just I wanted to try something a little bit different than the sort of usual F1. And because oftentimes, like how your model performs obviously depends on sort of the error measure you're using, in a way, and so, or how you interpret the quality of the model depends on the measure you're using, and it's just better to use something that's a little bit more balanced, so you don't have to sort of think too hard about how well it does. Yeah. So that, in a nutshell, is why I'm using the Matthews correlation coefficient.